This video is to show you how to make this polygonal cylinder that you see on the screen. So a polygonal cylinder is just a cylinder with a cross section that's a polygon, and I allow you to change the number of sides on it. You can see it just continues to get more like a completely circular cylinder as you change those. You can change the length, and you can change the kind of cross-sectional area of it by changing the length of the sides on the polygon. Okay, so if you want to learn how to do this using code in Unity, keep watching. By the way, this is the URL for the repo, and I'm going to put the link to the YouTube video right here once it's uploaded. I'm going to start by creating a new Unity project. It's going to be a 3D project. I'll name it Demo Polygonal Cylinder. I'm going to create it, and that's going to take a second to create, so I'm going to pop over to my terminal, and I'm going to get into the project folder that it already created. And I'll get into that assets folder, and this is where I'm going to pull down my Git repo. So git clone, my Git repo address. I should have renamed the folder that they go into scripts right here, but I'll do it in a second. So I'm going to open up VS Code at the root of my new project, and I see that my scripts are in there. They're in a misnamed folder, but I'll fix that in a second. So rename this to scripts. Now I'm going to also create a folder while I'm down here called materials, and it's just going to hold one material right now, my mesh material. So I'll create material. I'll call it mesh material. And now I'll delete this main camera. We don't need that. We also don't need the directional light, but I'll leave it because it provides some light. I'm going to rename the scene while I'm doing this to something that makes more sense. Okay, now create an empty object, call it mesh, and to this object I'm going to add a mesh filter and a mesh renderer component. I'm going to create another empty object now and call that mesh maker. And now I'm going to add two scripts to this new mesh maker object, the mesh maker script and the mesh drawer script. And on that mesh drawer script, I'm going to add the mesh as the mesh filter and also the mesh as the mesh render because it's got both of those components. And I'm also going to the mesh, I'm going to add the material that I made. And now I'm going to just change some of these parameters in the mesh maker object and generate the mesh. I'm going to go back to the mesh and press F to focus on it, and there's my mesh, there's my cylinder. So you can see that it's transparent on one side. I'm going to fix that by going to the asset store and searching for double-sided shader, and it's the second one here. I'll enlarge it. So just grab this. I've already downloaded it myself, so I'm just going to go into my package manager, and I'm going to find it and import it into this project. So there it is. I'll import it. I'm just going to take everything in the everything that's suggesting. And once that finishes importing, I'll be able to change the shader on my material. So I'm going to change the color really quick. Just make sure that it's changed real quick. Yep, it's red now. Looks good. So now I'm going to go back to the material, not the mesh, the material, and change the shader on the material. Just click through all these options, and I just chose this opaque one. And now you can see that both sides of it are shaded. Now I'm going to just mess with some of these parameters. Click the auto update. So now it's auto updating. Every time I change a parameter, it's going to update. So you can see I'm increasing the number of sides in the cross section until it essentially becomes a circular cylinder. I can change the length to 10, so that makes it really long. Got to zoom out a little bit. Change it back to something shorter. And you can also change the side length on the polygon, so that changes kind of the cross-sectional area. And the length and the polygonal side length are both floats, whereas obviously the number of sides is an integer. I've just made it really big right there, had to zoom out because each side length is 10 there. Okay, so that's what it looks like. Okay, let's go through some of the code here. So when you're clicking things and changing values here, the code that makes things happen when you change those values is here. So if auto update is checked, then it's going to call this make mesh function. And otherwise, if it's not checked, you can just always manually click the generate mesh button and it'll call this make mesh function. So that's the whole file here for the editor mesh maker, and it calls into this mesh maker that calls make mesh, and it finds the drawer. So this is the script that you attached. This is the other script. So we attached two scripts to this, the mesh maker script and the mesh drawer script. And so it finds that drawer. And I suppose I could have done that way down here where it actually uses the drawer. Just go ahead and move that just for just for clarity. Okay, so then we get the texture, then we get the mesh, and then we take both the texture and the mesh to draw the mesh. And that's basically all that happens in here. And the texture is just this simple texture. I'm fairly new to Unity still, so I'm not sure if this is actually needed or what this is used for. So I just included it because an example of a different program that did similar things used a texture, and so I assume that it's necessary. Okay, so let's go into some of these other guys. So the get texture function's right there. So what is generate mesh data doing? So that's going to call this polygonal cylinder class, and and when you instantiate it, it goes ahead and makes the mesh, and then you just get the mesh data off of it and return that. So this polygonal cylinder class, when you instantiate it, it says generate polygon cylinder. It creates a polygon, and when you create the polygon goes ahead and sets its vertices. So essentially what it's doing here is it rotates the point 1, 0, or if your side length is different from 1, say you had a side length of 2, it would rotate the point 2, 0 around the z-axis, so in the xy plane, to generate all of the vertices. So it defines the angle by the number of sides. For instance, if it's a hexagon, it's going to have 60-degree angles. So this is 2 pi, 360 degrees divided by 6. So that'd be 60 for a hexagon or whatever. And so it's going to rotate it 6 times, essentially, to get all of the vertices. So it's just taking that point 1, 0, rotating it and saving off the vertices. And this angular UVs, this has to do with how you're stretching the texture upon the mesh data. But the way I think of it is it's just giving the percent it's gone around the circle in that direction. So, each of these, like the first rotation, it's gone 60 degrees around, and then the second rotation, it's gone 120 degrees around. So in terms of percent of the whole way around, after the first rotation, it's gone 1/6 of the way. After the second rotation, it's gone 2/6 of the way, and so on until it's all the way around. So it's stretching it in that angular direction. That's why I called it angular UV. There's also the length UV, because the texture has to be stretched. This two-dimensional texture has to be stretched in 2 dimensions. So we've identified how to stretch it in the angular direction here, and then stretching it lengthwise is just, well, I only use one giant triangle in the length direction. So we're just going from 0% to 100% on that one. So that one's easy.
The angular one is the one that we kind of need to calculate. So let me go back to my polygon cylinder. So we're generating the polygon cylinder. So at first it generates the polygon that gives all the vertices for the kind of cross section of the cylinder, and then it builds the mesh. So let's see what build mesh is doing. It calls this stack polygon. So it just resets the mesh data, just make sure it's blanked out, and then it stacks the polygon. And essentially what it does is you can stack any number of polygons on top of one another if you wanted to divide the length into, multiple sections of length, but there's not really a reason to do that. So I just say, hey, stack a polygon and like put the two polygons, put one polygon at z equals 0 and the other polygon at z equals length. And then what this function does is essentially calculates all of the vertices and triangles necessary to connect up those polygons. So this essentially generates kind of the sides of the cylinder there. And you can read through that later on your own, but the important parts here is that if you're not using double shading, so originally when I made it and I didn't have the double shader on there that I got from the asset store, these triangles were only visible from one side, and they're visible from, I think it's the clockwise side. So if I put these vertices in this order, then whatever the whatever side you look at that triangle from to where these are in clockwise order, that will be the side that you can see the shading from or the texture from. The other side, you won't see anything. It'll be essentially invisible because it's trying to kind of save space or, save computational power if you don't need to look at something from both directions. Okay, so if you wanted to not use the double shader, all you'd have to do is you just have to add more triangles here and more vertices, and you just switch two of these, switch any two of them. You would invert the kind of parity of this triangle and you'd be able to see it from both sides, but you'd have to create twice as many vertices and twice as many triangles to do that. And yeah, you can reuse some of the vertices and stuff. I don't reuse them in this. This is a very simple implementation. Not really a reason to reuse them, because the reason to reuse them is to kind of share, make make them share their normal vectors a little bit, or like so that the shading is more smooth from side to side. But really, I want the normal vector to be normal to the triangle on every one of these. So if you think about it, and I'll let you think about that on your own rather than me try to explain it to you, but this is a fine way to do it for perfectly flat surfaces like the sides of this polygonal cylinder. Okay, and then you can see where I'm calculating the z length. So like I said, this would work if if this wasn't 0 in length I put in here. So I could put 0 and half the length, and then half the length and length in here. So I could call this twice and divide the length into two pieces, and this would still work, and it would calculate 0 to half the length. These UVs in the length direction would both be this one would be 0 and this one would be 50%. And then the next time when I called it length divided by 2 and to length, this one would be 50% and this one would be 100%. So it's just how far it's gone in that direction towards 100%. Okay, so that's that, and then so that's all it does. It creates this mesh data. It adds all the and so let me show you what the mesh data object looks like. So mesh data it has vertices, the triangle indices, and the UVs. So this is almost exactly the same as the mesh data that Unity uses, except Unity calls these just triangles instead of triangle indices. So you can see down here, I essentially like convert this custom mesh data object into the Unity mesh, the one that Unity understands, and you can see I'm mapping the triangle indices to the triangles, but these are really triangle indices, so that's why I call them that. But you can see all this. Every time it adds a vertex, you have to add, for each vertex there's a UV saying what percentage have I gone in both of the two directions, in the angular direction and the length direction, when I'm at this vertice. And it returns the index of the vertices so that you can collect those indices and then send 3 vertices in for every triangle that you want to create. Okay, so I think that's all I wanted to say there. And when you create the mesh, I have it calculate the normals. You could easily define these normals yourself, but I just have Unity do that for ease. Also, there's this demo data, so if the first time you're running this, if it's not working or something, you can just uncomment this and return this demo data instead. So let me show you what that will look like. Mesh maker and generate mesh, and let me go to mesh. So that's this. Sorry, this is what it looks like. So this is double-sided. If I didn't have the double siding on, one of these sides would be basically like transparent and visible, and the other side would be visible to you. So if the first time you don't see it when you focus on it, maybe you're on the wrong side of it, maybe turn it around. But you should see a square if you use this demo data. If you don't use the demo data, then you'll just see this cylinder again. Let me generate it again and focus, and there's your cylinder. Okay, so that's basically all of it. So here, let me go back to this mesh maker. So we've seen kind of how the mesh is generated, and then we just draw it, and that's it. And drawing it is just this simple function here that you can review on your own. This mesh data util, we were just kind of looking at this, but it's got the mesh data in it that, where you can add the vertices and then add every 3 vertices, you can add the triangle indices to it, and you can print out the triangles. I am printing out the triangles. So if you look at the console, you can see triangles used here. These are all the triangles that it used to build this object. And so you can take a look at that. It also prints out the number of triangles that it used. So number of vertices, number of triangle indices. These two should match because I'm never reusing a vertice. And sorry, these two will always match even if you do reuse vertices, but they're all distinct for me. So this triangle indices is literally just an array from 0 to 17. And then the num triangles is 6 because each of the 3 sides here has 2 triangles to kind of make up the rectangle. So 6 triangles used. And then if you wanted to know the coordinates again, you could just look at these. Okay, so that's that. That's the mesh data. This is the triangle. This is what you're seeing there. This is where I override the toString method. And I guess that's about it for the mesh data util class. And that's about it for the code. Thanks for watching.